Hello everyone, this is Joe Neville. Welcome to another Aruba AOS-CX Basics video. In this episode we're going to talk about Link Aggregation Control Protocol, or LACP. These videos are more about show than tell. We'll do a quick recap of what LACP is, and then we'll dive right into the configuration demo. Let's think about the why of LACP then. Imagine we've got two switches here with a single link. Now, single points of failure in networking are never a good thing. Wouldn't it be great if we could introduce a second link to increase our reliability, but also to increase the bandwidth between our two devices? But what's the problem with just plugging in an extra link here? Layer 2 loops, of course, which are generally a very bad thing, causing broadcast storms, Cat 1 tickets, sites down, and all those bad things. To prevent this, when we have multiple links, we have spanning tree to prevent these loops. But how does it do that? By blocking ports. So that's not what we're after. Here's our wish list. We would like to aggregate links together to increase reliability, but also bandwidth. We don't want any loops, of course, but we don't want to block the ports. Step forward, Link Aggregation Control Protocol, or LACP as it's known to its friends. That's the why of LACP. Now on to the what. Increase reliability and bandwidth without layer 2 loops. Got that? The aggregated ports can be layer 2, so switch ports, or layer 3, so routed ports. There's different types of LACP. So you can have, on AOS-CX, you can have static or you can have dynamic. Static are local only, so local to a single device, where the ports are aggregated, but there's no signaling with the other end of the link. So not great for failover. Dynamic is where you have signaling, and dynamic is subdivided into two types, one being active, where a switch will actively transmit the data unit, so the LACP DUs, to the far end, and passive, where the switch doesn't. This is where you get these quiz questions around LACP about the combinations of configuration. If you have two switches that are configured as active and all of the rest of the configuration is correct, then the links will be aggregated. If you have one end active and the other end passive, then those links will be aggregated as well. But if you have two passive ends of the links, there will be no aggregation. At least one end has to be active when you've set dynamic. A few words on what not to do with AOS-CX LACP. It is not compatible with Mac authentication, port security, 802.1x, and ports that you want to aggregate as part of a LAG cannot be members of a port mirroring group. We're going to go through two configuration demos. First of all, I'm going to configure a layer 2 link aggregation group, and for this I'm going to use my two Aruba 8320s running AOS-CX, of course. I've got -1 on the left here and -2 over on the right. I've already physically cabled them up with the interfaces shut down, so we've got no loops. What we have is 1/1/10 connected to the same port on its neighbor, and 1/1/11 connected again to the same on its neighbor, and those two ports will be put into a LAG. Now that will be layer 2, as I say, so we have the choice of whether that is access or trunk. I'm going to configure a trunk and allow VLAN 150 to flow across it. And I'm going to configure a layer 3 interface for VLAN 150. Put a V6 address on it, and the same again over on -2, so that we can ping across our LAG and see if the traffic is flowing successfully. For the second demo, very similar, but this time moving to a layer 3 LAG. So it's the same hardware, same ports connected into the LAG, but now there's no VLAN running across the link. So it's a layer 3 port, and the V6 address will be directly on the LAG. Once that's configured correctly, we will be able to ping from switch to switch. Let's dive into our first configuration demo. This is for the layer 2 LAG. Top left, I've got my 8320-1, top right is -2, and then down here on the right, I have a small diagram of the network that we're setting up. The configuration for -1 has a lot of config from the IPv6 videos that I've been recording in parallel, but that shouldn't affect this demo. The main thing is that the physical interfaces, so 1/1/10 and 11, are not known to the device. There's no interface VLAN 150 yet, and there's no lag. Same again over on -2, which is a bit lighter on the configuration. So without further ado, let's dive in and start our config steps. First thing to do is to create the lag, and you do that just by entering interface lag and then the number that you want. So that's created the interface now for us. Then we just go and configure it like any other interface. So it starts off as layer 3. We want layer 2. It's the same command as you would use on a physical interface, which is no routing. Now it's layer 2, and we've got that option then. Is it going to be access or is it going to be trunk? I said we're going to configure a trunk, so we enter the command VLAN trunk and it will be allowed 150 for our setup. Now let's look at some LACP specific commands. So if I enter LACP, our question mark there, we've got fallback, mode and rate. So fallback is for your multi-chassis lag when you're configuring VSX, which we are not. I'm just keeping it basic and traditional with the standard lag. So we don't need the fallback. The mode, if I enter mode there and do a question mark, you can see it's active and passive. So if you remember, LACP is divided on CX into static or dynamic, and then dynamic is subdivided into whether you want signaling or not, whether it will be active or passive. So if you don't enter a mode, you will be in static, which is the default of off. If you enter a mode, then you will be essentially dynamic, and you choose what flavor of dynamic you desire, so active or passive. I'm going to go for active. Remember, for this setup, one of the ends has to be active. And then finally, we have rate there. So you've got the option of fast or slow. Slow is the default, and that means that the heartbeat is sent once every 30 seconds. Fast, 1 per second. If you're aggregating between two devices that are indirectly connected, you may want to go with fast so that the heartbeat can detect if one end of the link is down. We've just got a simple setup with a single physical wire creating a back-to-back connection between two switches. So if one end of the link goes down, the other end of the link will go down almost immediately. And thus, for this simple demo, I'm going to stick with slow. So nothing to enter there for the rate. Let's come out of there and I'll show you the configuration for the lag so far. So it starts to shut down. So I need to no shut that. As you can see, no routing. This was entered automatically. So native 1 for the VLAN on the trunk. Allowed 150, and we've got the active mode there. So actually, I can copy that to save time. I can copy that across over to -2. Let's go into -2. I'll just paste that down. Good. Show run int lag 1. And there you can see we've got our configuration. Now, I should add in my layer 3 interface. I'm going to do that now, and then finally we'll do the physical ports. So while I remember, let's go VLAN 150, and it's a V6 address that I'm going to add. 2001 DB8 A 150::1/64 of 64, please. Of course, IPv4 will work very much the same as IPv6 in this scenario, but I'm always encouraging people to not be afraid of V6, to start using it in your lab. If you don't know anything about V6, I will always encourage you to do so. I think that comes up as no shut, but we'll enter that anyway. I'll do the same on -2, so interface VLAN 150 IPv6 address 8A 150::2/64. Shut. Good. Come out there. Save that. I don't know whether I say no, that I haven't saved that, so we'll save that. Good. Right, now for the physical interfaces. So if you do a show int on 1/1/10, it's admin down at the moment. Okay, let's go into there. 1/1/10. And we add it to the lag with lag and then the number. So it's just lag 1. We'll no shut that. Up arrow to 11. Lag 1. No shut. Same on this side. Lag 1. Okay, so now doing a show interface 1/1/10, you'll see it's down, but it's lag disabled. And the reason for that is because lag 1 is still shut down. Okay, and it'll be the same on the other end. So we need to go into the lag. It's lag 1, no shut. And on the far end, lag 1, no shut. Come out of there. Okay, so show interface lag 1, and we are up. Okay, what I will do now, let's go through some show commands then. Let's step you through those. Show, then it's LACP. And then we've got these three options here. So we've got aggregates, configuration, and interfaces. I'll go aggregates. And here you can see, so this is good for looking at all the lags that you've got on a switch. We've only got one, so it doesn't have so much information. But if you had multiple on the device, this would be a good command. It gives you an overview of the details. So you've got the aggregate name, the interfaces that are assigned to it, heartbeat rate, the hash. I haven't delved into that for this demo. If you want much more information about link aggregation with AOS-CX, check out the configuration guide. I'll put a link to that in the description. The config guide does actually give you a lot of information. And then finally, we've got the aggregate mode, which, if you recall, we've just set as active. So let's move on to the next one. What do we have? Okay, configuration. So this is just system wide. You've got the system ID and the priority. For this demo, I'm not going to touch that. And then finally, this gives us a lot of information. Show LACP interfaces. There now. We've got, because it's up as well, we've got a lot of information in there. So we have the interfaces, the lag that they are assigned to, the IDs, the priority. Now the state, you have all of these different flags, and you've got the abbreviations up there actually. A bit more detail about this in the config guide. So you've got active there, that's because we configured that. Long timeout, so slow. Then we've got various other flags as well, which you can look up if you so wish. The system ID, so this is local, system ID, priority, and this is important, of course, the forwarding state. So that the local is the actor, and then the far end is the partner, so details about the partner. Now when I first looked at this, I thought the system IDs were the same, but they're not actually. They are different. So if you look 2778 0728, okay, so these are two ends of the link, and why they know about each other is because of the signaling with the LACP DU, the data units that are being sent across the link. Now that other command then, you don't have to go LACP specific. I've already showed you this, bit of a spoiler alert, you've already seen this, but if you just do show interface and then the lag number, that does give you LACP specific information. So you've got the aggregated interfaces there, the key, the mode that we've got set up, and some other interesting information about the port configuration. So the fact that it's a trunk and we're allowing 150. So let's try and do that ping. So it'd be ping 6 2001 DB8A 150::2. Bang. Okay, so we are pinging across the link. Down on our diagram, it's across this aggregated link that we can ping. Now let's move on to the second demo, which is a layer 3 lag. Here we go with the layer 3 lag demo then. Down in the bottom right, I've changed the diagram, so now we are going to configure the lag itself with an IPv6 address. And on the device, it's easier to show you on -2 actually. On the device, what I've done is I've reset it, so I've taken off lag 1 and the physical interfaces are now shut again. Oh, and of course the layer 3 interface VLAN 150, I've removed that so the IP address doesn't clash. Same on -1, no VLAN 150, no 1/1/10, and no lag. Okay, So starting with -1, so again, interface lag 1, okay, and because it's layer 3 by default, we just put the L3 address directly on the interface. Let's go, so the mode, I'll go with active this end. Let's go for LACP rate of fast as well. Make things a bit different. I'll no shut that. Show run int lag 1. Over on -2, I'll bring this across. v6 address A150 to 64. Let's go for LACP mode passive, and we'll go, let's put the rate of fast as well. No shut that. Come out of there, show run int lag 1. Okay, looks good. So now we need to go into the interfaces. Same deal, lag 1, no shut. Then with 11, no shut. Lag 1, no shut. Okay. Come out of there. Show LACP. Let's go interfaces to start with and pull that across. Okay, so interfaces is showing the ports against the lag. Now the flags are slightly different. So we've got active there. We've got the short timeout. If you remember from the first demo, we had L there for the long timeout. So that's shown up there. We're up, which is good. Now it'd be interesting to go across to -2 actually, and have a look at the flags for that. Let's come out of there. So show LACP interfaces. And this is the, remember that I've set it as active and passive. To pull that across so you can compare the two. So it starts with P, you see, for passive. So you can see from the flags, one end is active, one end is passive. We are up, which is great. Let's go through some of those other configuration commands then. So show LACP, what was the other one? Aggregates. Yeah, you can see active there. Heartbeat is fast. And over here, that one should show us passive aggregates. Okay, yeah, so we're showing passive here. Right, what was another useful command? So just in lag 1, you can see the interface is assigned. We're active. We've got our speed because that's the combined rate of the two ports. Show in lag 1, and there you can see passive. We should be able to ping 8A150::2. That's correct, isn't it? Yeah, okay. And we can ping, so that's good. Right, now what if, as a final point then, what if we go into the lag 1, LACP mode, let's go passive both ends. What happens? Okay, now let's scroll up there. As you can see, because we're passive at both ends, the state has actually been disabled, so the lag itself is down. Up arrow for that ping, now that's down, so the interfaces are essentially down. If we look at the physical interfaces, those are up, but the lag itself is down. Yeah, so that's disabled, so no traffic can flow across that. Let's move it to active, and now we can ping show int lag 1, and then we're back up. Okay, that's it for AOS-CX LACP. You saw that we configured a layer 2 lag, active, then a layer 3 lag, active and passive on the far end, and that was successful. The traffic failed when I moved the configuration to passive both ends, and the ping was failing. The lag was shut down. Move it back to active passive and it all worked. So thank you very much for watching. I really appreciate you taking the time to watch my content. Comments are always welcome. If you want to put those down, please give us a like or a dislike. Subscribe to the channel as always. It really makes a difference. But that's all for now. My name is Joe Neville. Thank you very much for watching, and goodbye.